This is the SHIS group presentation by members Jeanne Favaro, Alyssa Anderson, and Hailey Glass. We will be covering national parks in 3 different regions: the Great Lakes region, the Missouri Basin region, and the Mississippi Basin region. A common factor these parks have is the main watershed of most of these parks is the Mississippi River, which runs vertically through the middle of the United States. Hi, I'm Hailey, and in this section we will be going over the national parks in Region 5, the Missouri Basin region, which includes Wind Cave, Badlands, and Theodor Roosevelt National Park. We will first start with Wind Cave National Park, located in South Dakota. As stated by the Cave Geology article by the National Park Service, around 350 million years ago, this area was covered by a warm, shallow ocean. Seashells covering the ocean floor were made of calcium carbonate, which then turned into limestone and gypsum. When sea levels started to get lower, this allowed fresh water to enter the area. The acidic freshwater reacted with the gypsum and dissolved the limestone, forming the first cave passages 320 million years ago. Sea levels would continue to fluctuate for the next 240 million years and kept depositing more sediments into the caves. As stated by the Park Geology article by the National Park Service, around 65 million years ago, the Laramide orogeny occurred, which created the Black Hills and also brought the caves up to the surface and drained them. As you can see in this picture, you can find rocks dating back to the Precambrian era, as well as young Cenozoic era rocks. As stated by the Theodor Herring in the Wind Cave Paleontological Resource Inventory article, this area is also fossiliferous, meaning there are a lot of fossils found in the park, which include the Subcharodon, a small rhinoceros without horns, Leptomyrix, a small mammal that resembled a deer, brachiopods, including aquatic shelled animals, gastropods, including snails and slugs, and also sponges, turtles, lizards, and other mammals. Next is Theodor Roosevelt National Park, located in North Dakota. As stated in the Geologic Formations article by the National Park Service, around 65 million years ago, the Rocky Mountains were forming in the western United States, causing lots of uplift and folding. Sediments were being deposited from the surrounding mountains and building up in layers that you can physically see, like in this picture here. You can see all the layers stacked on top of each other. The sedimentary layers in this parks are made of sandstone, mudstone, siltstone, and also volcanic ash that was deposited here and turned into clay. During the Pliocene epoch, rivers started flowing faster and began to erode and carve away at the layers of the park. Then during the Pleistocene epoch, an ice age occurred which brought a lot of glacial activity to the surrounding areas and changed the direction of the rivers flowing through the park. This area is also good for finding many fossils, including clams, snails, alligators, turtles, and Champsosaurus, an ancient crocodile-like creature. Lastly is Badlands National Park, located in South Dakota. As stated in the Geologic Formations article by the National Park Service, there are many layers of sedimentary rocks exposed in the park. Deposition of the bottommost exposed layer from around 75 million years ago is evidence of the warm, shallow sea that covered the area during that time. After the sea levels dropped several thousands of years later, the area turned into a hot savanna-like climate. Around 500 years ago, the Cheyenne and White Rivers began to carve away at the layers covering Badlands, creating channels and canyons. In the layers of Badlands, we can see sedimentary rock from different climates and erosion from the Black Hills, as well as some volcanic ash from eruption that occurred in the surrounding areas. The rivers running through Badlands have exposed the many sedimentary rock layers, and also all the fossils that are in them. This area is full of fossils like Mosasaurus, pictured in the slide, which is a marine reptile that ruled the sea in this area. According to the National Park Service Geodiversity Atlas for Badlands National Park article, this is also a fossil-rich area, and fossils here include 50 species of herbivores like Titanotheres, an elephant-sized animal resembling a rhino, and also 14 species of carnivores. In this section, we will be moving slightly east from the Missouri Basin region into Region 3, the Great Lakes region, and discussing the glacial activity that occurred there. The national parks located here are Isle Royale, Voyagers, Indiana Dunes, and Cuyahoga Valley National Parks. There are 4 parks included in this region, however I will just be going over 3 of them: Isle Royale, Voyagers, and Indiana Dunes. Cuyahoga Valley National Park will be discussed in the next section. Isle Royale National Park is located in Lake Superior. According to the National Park Service Geodiversity Atlas, Isle Royale National Park, Michigan, The Lake Superior Basin was formed as a result of a few factors. These factors being a failed continental rift, a geological syncline, and glacial erosion. We can see the culmination of these results in the article Early Glacial History by Lakehead Region Conservation Authority. They state that Lake Superior was created by glaciers bulldozing their way through the softer rocks in the mid-continental rift, carving out what would eventually become the basin of the lake, as you can see in this image. The glacial ice later melted, filling the basin to create the lake we know today. The previously mentioned National Park Service article also states that Isle Royale is an archipelago consisting of one large island called Isle Royale and more than 400 smaller islands in Lake Superior. They also state that the glacial activity over the last 3 million years formed the topography of these islands. Another article from the National Park Service, Geology and Soils, describes that the geology of the islands changed from 4 glacial periods, the last taking place around 12,000 years ago.
Hello, I'm Jeannie, and slightly west of Isle Royale is Voyagers National Park, located in northern Minnesota, also near Lake Superior. Similar to Isle Royale, Voyager was also affected by glacial activity. We can physically see this sort of activity here in the park in a couple of ways. One of these ways is, as stated by the NPS Geodiversity Atlas, Voyagers National Park, Minnesota article by the National Park Service, that we can see glacial activity in Voyagers through the deranged hydrology and glacial erratics found there, as seen in the top right image. We can also see the physical marks left by glaciers as they travel through this area through the striations left from the scraping of glaciers against rocks, like in the bottom left image. This same National Park Service article also states that through these striations, we can determine the direction that the glaciers were moving. The scrapes in the rocks would align in the direction of glacial travel. From Voyagers, we will now travel southwest to Indiana Dunes National Park. Indiana Dunes is located in northern Indiana and is adjacent to Lake Michigan. Similarly to Lake Superior, glaciers also create what we now know as Lake Michigan, as shown in this image. In the article Natural Features and Ecosystems by the National Park Service, Lake Michigan formed sometime around 11,000 years ago when the Wisconsin Glacier, which was the last glacier to envelop this area during the time of the Ice Age, started to melt. The article Geology of Indiana Dunes National Park by the United States Geology Service, or USGS, states that the glaciers traveled through the path of least resistance, the weakest area, to form the basin, similar to how the Lake Superior Basin was carved out. This same USGS article says that moraines also played a part in creating the basin that we would come to know as the Great Lakes. The USGS defines moraines as a general term for unstratified and unsorted deposits of sediment that form through the direct action of or contact with glacier ice. The moraines would come to help define the Great Lakes Basin. Indiana Dunes National Park also has ponds and wetlands in the lower regions in between dune ridges, according to the same USGS article. Geology of Indiana Dunes National Park, these areas were formed by the movement of groundwater through coastal landforms, as well as glacial landforms. The final park in Region 3 is Cuyahoga Valley National Park. For this park and the parks in Region 4, we will discuss sedimentary rocks found at each park. Established on December 27, 1974, Cuyahoga Valley National Park sits roughly 20 miles southeast of Cleveland, Ohio. According to Shaping the Valley article, 400 million years ago, an ancient sea covered the northeast part of Ohio where silt, mud, dead fish, and dead sharks sank to the sea floor and over time got stacked in layers, then crushed and squeezed to form Ohio shale. According to Geology of Cuyahoga Valley National Park article, above the shale is a Brea sandstone layer, and billions of grains of sand were deposited into river deltas that eventually cemented into sandstone. The third and final region covered is the Mississippi Basin region, the fourth region on the map. The parks we will look at today are Gateway Arch and Hot Springs National Park. Starting with Gateway Arch, the most boring park, geologically speaking, in St. Louis. The park was established on February 22, 2018, and looking at the photo on the right, provided by the Plants article, the park is made up of turf grass, bald cypress, zen gardens, native grass meadows, and an explorer's garden. The Geology of PAGE article notes that the arch is 60 feet underground and anchored into St. Louis limestone. The limestone built up in this area because it was once shallow, warm water with sea creatures that then died, accumulating at the bottom, lithifying into limestone. Finishing with Hot Springs National Park, it was established on March 14, 1921, and is located in Arkansas. The Hot Springs Geology article stated that the environment was deep ocean during the Carboniferous period. Sandstone, shale, and chert are just some of the rocks found due to the sediment collecting at the bottom of the ocean as the Wichita Mountains began to form due to erogenic events, as stated by the Geology of Hot Springs National Park article. We hope you enjoy a tour through Wind Cave, Badlands, and Theodor Roosevelt National Park fossil hunting, Voyagers, Isle Royale, and Indiana Dunes discussing glacial activity, Cuyahoga Valley, Gateway Arch, and Hot Springs collecting sedimentary rocks. However, due to climate change, these parks are in danger of changing in ways that affect their beauty and importance. In the past, these areas have been affected by changes in climate, such as the glaciers in the northern Midwest and the high water levels covering most of the West. With the continued use of greenhouse gases, climate change has threatened many parks with rising temperatures, which can result in longer and more severe fire season, drought, and loss of plants and animal life, like projected at Theodore Roosevelt National Park, according to the climate change article. This can be prevented. We're not at the tipping point yet, but changes need to start, and it can start today. Thanks for watching. The last few slides are for our bibliography.